Hello, welcome back. In this video, we're going to take what we've learned about the radian and the unit of measure we call the radian, and sort of build on that and ask some slightly different questions. So what I wanted to do first was just make sure we understand what we learned in the previous video when we defined what a radian was. So if I were to ask you, given a circle that has radius equal to 1, and I told you that, let me draw this here, say the radius, let me draw it underneath, how about that? The radius is equal to 1, and I tell you that we have some angle, we'll call this angle theta, and I say that that angle measure is equal to 1 radian. If I say that this angle measure is 1 radian, this amount of openness is 1 radian, and then I were to ask you what, and we'll do this in a different color, hoping you could see this. If I were to ask you what the measure of this arc segment is that is cut off by this angle, let's call this arc S. If I were to ask you what is the length of that arc, what would you tell me? Well, if we understand that when we have an angle measure that is 1 radian and the radius is equal to 1, then by definition the arc length S is going to be what? It is going to be the length of 1 radius. That would be 1. Let's go to our protractor app and experiment with this. Okay, so here I've set my openness to be 1 radian, my angle measure to be 1 radian, and let's make our radius, just to make sure that our thinking is correct about this. If we make AD, this measure right here, 1 radius, or 1 unit rather. Okay, again, it gets really difficult when the circle gets small to be fine here, but the point is that the length of the arc that is cut off by a 1 radian angle measure when the radius AD is 1.03 feet is of course 1.03 feet. We may, not where I want it to be. Let's go back here. There we are. And I'll do this a little bigger this time. Let's say now that we have a circle, and I tell you that, all right, it has a radius of 2, and that we have another ray in this circle that forms an angle of 1 radian, and we ask, what is this length? If the angle measure we're dealing with is 1 radian in measure and our radius is 2, well then that means that this arc length S is going to be the length of 1 radius, which is 2. Let's maybe change this question to, let's say we're dealing with an angle measure of, say, 2 radians. So we're going to have to make this longer. In fact, twice as long. All right, so maybe we're there. Break that up a little better. That would be an angle of 2 radians, and now we're asking I said radius is 2, we have an angle that is subtended by an arc of length s, and our angle is 2 radians. Well then, point I'm trying to make, if our radius is 2 and our angle subtended by s is 2 radians, well then this has to be the length of 2 radii. So s in this case is going to be 2 in 2 radians in length. Right. Okay, so in exercise 2, we are given an angle measure that is 0.45 radians, slightly less than a half of a radian. All right, maybe we could draw this picture a little better than the one we're given. So we have an angle measure that is, if this is our radius, we would want something a little smaller than half of that length to be the, all right, so maybe this is our theta, and we are asked to determine the length of this arc, which again we're going to call S, given that the length of the radius is 2. The radius is 2. So if our radius is 2, that means that the length of 1 radian would be 2 units in length. So then all we have to do to compute this is say, okay, I'm going to have 0.45 of a radius. So that's 0.45 of a radius. And 45 times 2 would be 90. Moving the decimal twice, that would be 0.9. And if our radius is 2.4 inches, that would mean that 1 radian would be 2.4 inches in length. So we would take our angle measure, which is 0.45 radians, times 2.4 inches, and that gives us what? Plugging that into our calculators, we have 2.4 times 0.45. That gives us an arc length of 1.08 inches, and so forth. For 2.9, we again multiply our angle measure by the size of the radius, which is 2.9, and we get 1.305 inches. 1.305 inches, and so forth. Now, I hope you're seeing the pattern here. In general, when we're discussing when our unit of angle measure is in radians, we can generalize this. For any circle, the arc length that is subtended or that subtends an angle theta in radians. To compute this arc length, we simply multiply it by the length of the radius. Okay, so in 2b, if we use the reasoning we established in part A, that is for any circle, arc length S will be theta in radians times larger than the radius. When we're asked here to define a formula that relates the arc length cut off by this angle, well, any angle in a circle, the measure of the angle in radians and the radius of the circle in inches. And we're asked to justify our formula. Well, we've done that. They haven't told us to put S in terms of theta or R, so forth, right? But we could also say that for theta in radians, dividing both sides of this by R, that it will also be true that theta will equal the length of the arc divided by the radius. And it's important here to consider the a functional relationship between these three quantities here. Here, we're saying that the arc length s, as we've seen, is going to be theta times the length of a radian, or the length of the radius. Here we're saying, in the case of theta equals s divided by r, we're describing an angle measure in radians as the number of radius lengths which comprise a given arc length of a particular circle. We could also represent, this is one way, another way, we could also represent this in this manner. We could put the radius in terms of the arc and theta. And if we think about this, this is saying that we could find the length of the radius. We could find the length of the radius by finding out how many times larger the length of this arc S is than the measure of the angle in radians. Okay, so I'm thinking for exercise 3, it might be useful to think of this, or begin to think about this in the context of a picture. All right. So it says, what percentage of a circle's circumference is cut off by an angle? So we have some angle that is 35 degrees. So let's sketch our 35 degrees, right? And again, we're asked for a percentage, so we're ultimately going to want to figure out what percentage of 360 degrees that gives us, and maybe we can sketch a 35 degree angle. That would be our 35 degrees. Okay, plus another 1.5 radians. So plus another 1.5 2 pites will give us our percentage. All right, so we want to go 1.5 of these lengths, 1.5 of those lengths. So I'll do my best to draw that. So that's going to be, I don't know, I'd say about there. Let's see, 1.5 of these. I know I'm not really drawing the circle very accurately. Let's see. Okay, so I don't know, 1.5 radians, so that would be one radius length. That might be one radius length, or 1 radian plus another half. I don't know, maybe we're there. Okay, so that would be 1.5 2 pites from here. Okay, and if we did this, plug this into our calculators, we'll get that this is roughly about 33.6% of the circle's circumference.